Fine. So today we are just going with the introduction with the IoT and the available IoT boards at present. So what's basically IoT is like from bookish definition when we go, it's like your Internet of Things. So what's basically Internet of Things? What I concluded this term to be as when we are having any embedded system, like providing any embedded system the capability to communicate using internet or a long range communication. It's a part of IoT. It's basically an IoT. When we talk about like the home automation systems, when we talk about smart cars, when we talk about smart devices, when we talk about wireless sensor networks, these are all basically the domains available in the IoT. And basically, what IoT does is it's like a building block or a connecting block for various new technologies which are coming, like your blockchain, like your AI, like your data analysis, big data. IoT is a basic mean which provides that data to be a like for a data analyst in a big data domain to analyze that time, and that data will be used by an AI system to basically automate things, to basically control the things, or to basically like help the user to provide a systematic way to solve something. This is what IoT is in a very short, very strong manner. An embedded system plus the internet connection or any long range connection we can consider. When we add these two things together, that's your IoT product. So if we take into an example, like we have now the smartphones, and with the smartphone, we have the automations of the home. Like we want to turn on any appliances. It can be a TV, fridge, can be a AC, it can be a fan. You can do that. If you just want to control the temperature of your room from anywhere around the world, you can do that. These are the examples for the IoT. Fine. So, like, to basically start with this, we will be requiring some medium. So that medium is basically your embedded system. So the main role for an IoT device or IoT product or IoT project will be that embedded system part. How we are basically making that. That will be basically helping. Like we just have to put an internet connection or any communication connection with that embedded system, and we are good to go. We are able to convert any embedded device into an IoT product or IoT project. Fine. So the basic element in the embedded devices is your microcontrollers, microprocessors, or your development boards. So today we are basically going to learn about those which we can use, which are goods, like what are their advantages, what are their disadvantages, and how we can use like is there any way to overcome those advantages or disadvantages or not. Fine. So let's start with this. And our very first development board is your very common one is your Arduino. Now Arduino, which is a basic like a confusion with many students when we just read about Arduino, they used to tell Arduino to be a microcontroller, but this is a little wrong. Although it's basically like it uses a microcontroller, but the main thing is Arduino itself is a platform, a development board. It's not a microcontroller. This chip inside the Arduino, like the Mega chip, is basically your microcontroller available into that board. So whenever anyone like ask you what is an Arduino, Arduino always tell them it's a development board which helps the new techies to have a hands-on on different devices, different equipments, without being knowing the in-depth of the embedded coding. If we just have the common like knowledge, a base knowledge of the C++ programs, then we are good to go with this Arduino board. Now, this Arduino board is an open platform, as we all know, and there will be two things for this Arduino board. Like one is your hardware device, which is your Arduino board, and the second is the software device, which is your Arduino IDE. Fine. Now the IDE is basically used for the compilation, checking for your errors in the code, and which will be used to like basically to provide that what functionality we are going to provide into the chip, and how this function should be working with the Arduino board. So let's just see how like what are the components available in this board. Now when we like go with the IoT purpose or any embedded device, there are many things which we have to consider. Like uh, what what are the number of the digital pins there? What are the types of digital pins the system is having? Is there any availability of analog pins? Fine. And along with them, the most important thing, what is their clock speed? How much power they consume, and what are different power levels they can accept. Fine. So like in Arduino, we are going to have this like explanation. What are the different things available in the Arduino? Like the main first thing is your Atmega 3 to 8P microcontroller, which is the basically the brain, the main body of the Arduino. Like this is where your code is going to be stored out and where the logics will be coming. And to run this board, this crystal oscillator over here will be used, and it's a 16 megahertz crystal oscillator. Fine. It's a 16 megahertz crystal oscillator. This is the basic, like, and some resistors, transistors, and capacitors will be required for a proper functionality. This is the basic main thing other than the power supply, which will be required to first basically interface the embedded or basically the microcontroller. Fine. Other than that, we are having over this side, when we just see over this side, this is the jack of the digital pins available onto the Arduino. Like from pin number 0 to pin number 13, we are having the digital pins from D0 to D13. So on our average, it's a 14 pin or for the digital input output purpose. For digital input output purpose, what we have is like 0 is for the low or 0 volts, 1 is for the high. Why 1 is for the 5 volts output supply. Why I'm saying for the 5 volt supply, this is because of the reason this Atmega controller will be requiring at least a 5 volts to work. Fine. Now, the second thing is like this next thing which we are going to consider is what are the different ways we can put supply to the Arduino board. First, go to this side and we can see like this is the power lines available for the Arduino. We have a reset pin or reset button. We can also say like if you want to reset from the your whole system, whole program, you can use this button as well. Otherwise, if we are having some multiple connections of multiple boards, we can use this reset pin as well to restart the functionality. Fine. Then we are having a 3.3 volt supply and a 5 volt supply. If so, like this is in the case, some devices will be requiring a 5 volt supply to be working. Some devices will be requiring 3.3 volt supply. And there are also some devices which require 1.8 volts for their normal operations. Fine. So like the 1.8 volt devices might not be directly being used because we have to have an external circuit to first drop that voltage up to that voltage and then we can use it. For some, like most of the sensors, most of the devices, a 3.3 volts and a 5 volt is the most common one to be having. There are also some devices which can work on 3.3 volts as well as on 5 volts. Fine. Then we are having two grounds over there, two ground pins, which will be representing the 0 volt supply. And then we are having a V in pin. Make sure with this consideration, whenever you are going to provide a supply to the Arduino with this, like this is a V-in pin, it is supposed to be taking the input supply from the output device. Like it can be a battery source, it can be a direct DC plug as well. So just the thing which we have to make sure is like never ever cross a 9 volt supply for this pin. If we cross, like there is a in my experiments as well, whenever I cross this 9 volt supply for this pin, my devices burned out. So this is why this is because like this pin is not directly being attached to the circuit to first drop it to 9 volts, like from the 5 volts and then go up to the proper functionality for the board. What happens is that this track available for this 9 volt supply is not that big as provided for this jack, which is the main reason why we have a short circuit or why there is a chances of burning out because of this V in pin. Whenever you want to use this V in pin, you can use for 5-volt supply, you can use it for 9-volt supply to the Arduino. Fine. If you want to take the supply out from Arduino, you can use the 5-volt pin from this side or from 3.3 volts from this pin. Fine. Just make sure with this point VE pin will be max to max 9 volts. Then we are having a power jack, which is for external supply, like from the external supply you can use it, and this will be for 7 to 12 volts. So not a big limitation on this, you can use any, like from 7 to 12 it will be working very fine. Just make sure like up to 2 amperes it's good, not more than that. Fine. This is the main consideration, like we also have to take care about the how much amp ratings we are also sending to them. Fine. This is the voltage regulator, which will be helping you out to basically drop that 5-volt, like 7 to 12 volt supply or 9-volt supply to the 5-volt supply, and which will be used by your chip or the Atmega 328P. This is your USB plug, and this plug will be doing two functionality. One, it will be helping you to upload the code, or basically to have the data from the serial monitor or to the serial monitor, which will be seen. Like if we want to print something to our laptop's screen in the test functions, so how we can do that? This USB plug will be helping in that functionality, and also it will be supplying the 5-volt supply for the powering up of the device as well. Fine. Now the next thing is coming over here is this is your analog pins. Now like there are many sensors, especially your capacitance sensor or the moisture sensors, which works on only the analog values. They only provide a analog value, not a 0 or a 1 peak like structure or the pulse like structure. They have a continuous wave like structure or a sine wave like structure. Like it depends upon what they are going to send the value. So in Arduino, we are having the resolution of of 10 bits. So whenever we provide any analog signal, the Arduino will be reading that value from 0 to 1023. Like how it does, it will be taking the analog value, and the internal analog to digital converters will be converting that value to a range of number. So this range is from the resolution, and that is from the 2 to power 10. So which is going to be 1024, a max total values. Total 1024 different values. It will be starting from 0 and goes up to 1023. Fine. The main thing which we have to note about this is this Arduino can only be used to take analog inputs. It is not possible to directly generate an analog signal. If you want to basically generate a sine wave, if you want to basically generate a triangular wave, this is not possible directly with an Arduino. There are some boards which can generate it, but we can only take as an analog input rather than analog output. Fine. Now next last thing with the Arduino board is this LED number 13 or pin number 13 is being connected to an internal LED L, which is labeled over here, through an internal resistor. So if you want to just make sure your board is working correctly, you can we'll be doing that thing out. Like we can just go and plug this board with a laptop after installing the Arduino IDE, and then when just we put our first code, which is a blink code, and if this LED is blinking up, then we can are sure that our board is correct, it's working fine. It's just a test purpose pin, and like whenever we want to have some kind of test, we can have it in a use. So this is the main Arduino Uno board, very common board. Now let's just see the different types of boards available. This is Arduino Uno, this is Leonard, this is Mega, this is Lilipad, this is Mega. Like we have different versions of Mega as well. This is Atmega 2560 processor. This is Atmega ADK processor. This is the old one, this is the newer one. Fine. We have the Arduino Ethernet Shield, Arduino Pro, Pro Mini, Mini, Nano. Now, like it depends what kind of project we are going to make. What are the basically requirements for that? Like suppose if we require only 5 pins, 5 digital pins for a project, then there might be not a case we just require an Arduino Uno. We can just shift towards an Arduino Pro Mini or a Lilipad. if somebody wants to make some kind of like gesture control devices, then a LilyPad, a Mini or a Pro Mini is a very good option. If there is a space restriction, and you want this same basically the compatibility what the Arduino Uno is giving you, then you can surely shift to Arduino Nano as well, because like the processor is almost same, and there is also a very good advantage for the Arduino Nano is like in Uno we have seen like the analog input pins are from A0 to A5, like total in 6, but in Nano it's 8. So we are also having an external like extra advantage in the Nano as well. Once is of small size, and second it's having more number of analog pins. Fine. So this was different boards, and they can be used in different cases. Like if you want like a very if your system is very big, you want multiple input pins for like digital purpose, multiple input pins for the analog purpose, then we can go with the Arduino Mega itself. It's having 54 analog pins and 18 54 digital pins with 18 analog input pins. Fine. So this is basically the comparison chart, like when we just see about different boards. So like what are the processors they are using, what is their operating and input ranges. Like as we have seen, the operating range of our Arduino Uno is 5 volts, but it can take input from 5
Sir,
volts.
one thing, can you
Yes,
zoom it little bit? It's not clear.
yeah, sure. Is it fine?
Yes, sir.
So like the main thing is coming over here. Like let me have this Arduino Uno. Okay, yeah. We have seen with the Arduino Uno is like it works on 5 volts, but with the jack, when we see with the jack, its availability to have the working like the input voltage it can take up to is from 7 volts to 12 volts. Like it's 5 volts, it's compulsory. Above then that we can have 7 volts to 12 volts. Now you can see there's many different devices like the 101 is using at working at 3.3 volts only. The LilyPad works from 2.7 to 5.5. Fine. Now the micro, mega all works on 5 volts. Your pro board will be using 3.3, and there are also different versions of your Atmega chip which is built into it as well. Fine. So like you can see your pro mini is having Atmega 328p, your Uno is having 328p, your pro only the pro one can have Atmega 168 or 320p. It just depends upon what is the configuration what the manufacturing is producing. Like all three these boards are having same capabilities, just with the difference with the number of pins they are having, the number of like the amount of memory they are being having stored, like the SRAM, DRAMs available into that board itself, like the flash memory and the SRAM memory. Or even if the like we are going to use with the EPROMs, we can have that as well in different sizes as well. Now this is the main another important thing is your clock speed, which is basically in megahertz. So it can be 32 megahertz, 8, 16, 8, 16, 48, 84. So it depends like how much we require for our project, like how much fast communication or computation we require for the project. Then we can like choose the required board on that basis as well. So in case of Uno, it's 1600 megahertz, 16 megahertz, and your Nano also having the same baud rate, same clock speed as well. Now this is basically your the main thing, the analog input and output pins. This from this slash before is we are having the input pins. For the Uno itself, we are having only 6 input pins for the analog purpose, and we are not having any output pin for the analog purpose. But you can see there are some boards that the MKR 1000 is having one output pin for analog purpose, and your Duo Arduino Duo is having 2 pins for the analog purpose, for the output analog purpose. Fine. Then we are having the digital pins. Digital pins, as we know, they are only having 2 levels, either a 0 or a 1, basically a 0 volts or a 5 volt supply. So in Arduino Uno itself, we are having 14 pins, and then it's written as PWM functionality. It's your pulse width modulation. What its help is like it's basically help us to mimic if we are not having like there is always like if there is a disadvantage available in your board, then all the designers try to put anything which can be replicated with some kind of some limitations, but will be helpful. And that is what we are having over here. If we are not able to generate the analog direct pulse, what we do is we use this PWM functionality. We change the length or the width of basically the pulse, how long, for how long we want to change it. Like it can be of a 1 millisecond long, it can be of 2 millisecond long, it can be of 50 millisecond long. So this is what the PWM functionality help us. It basically helps us to mimic for an analog functionality. And the major use of this PWM pins will be in the case when we want to basically change the intensity of something, or we want it to like to control the speed of a motor. Then this functionality is very useful. Fine. And the rest is your like what is the available EEPROM memory which you can use, what is the available SRAM which basically requires for the how much computation power which we require, like how much variables we can have at the moment, the flash memory to storing your data, storing your code. And then we are having the different USB functionality as well. Like for Arduino we are having different types of USB pins, USB plugs. Like for it's nano, it's a normal B plug, micro B plug. For some, it's a regular Arduino plug. For some, it's a micro plug. It depends upon various boards to board. Then we talks about a UART. UART is basically your universal asynchronous or synchronous receiver transmitter. Fine. So like in Arduino Uno, we are having only one UART, like only one RX and TX. If we consider for the Mega over there, we are having two. But in case we want more RX TX pins for the communication part, we can just increase by serial software serial library to increase that functionality as well. Fine. So this is all about the Arduino board. Now, if we come to the advantages of Arduino board is one, it's simple to use. Second, the power utilization is not very big. Third, it's almost compatible with all the devices and having the availability of this analog input functionality as well. It can interface different analog sensors as well. And like this is the main advantages of your Arduino board. What is the basic disadvantage of your Arduino board is we cannot like its computation power, it's not that much big. If basically you want to have a like very sophisticated system, suppose if we want to like directly build some kind of a database onto the Arduino, it might not be possible. Or if we want to basically run a OS on this, it might not be possible because those things will be handled by an operating system, and which is not able to like we are not able to put that onto a microcontroller. For that we require a microprocessor, and that's why uh, towards the computation power the Arduino lags out. Fine. If there is any doubt till this point, you can ask. Anyone having any doubt till this point? Free, please free feel to ask.
No, no, sir.
Okay. One more advantage we can consider for the Arduino board is it's not very expensive. It's it is expensive, but if we consider for the if we just compare with other boards, it's not very expensive. Like there are some boards which are also like less costly than Arduino ones, but we can consider as an advantage for Arduino this thing as well. Now the next board which we can consider is your Raspberry Pi. Now the main thing which we consider with the Raspberry Pi, it's not a microprocessor, microcontroller, it's a microprocessor. Fine. So from the microprocessor word, you might be getting this point out, like the computation power, the computation disadvantage which was available in the Arduino will be directly be eliminated in case of the Raspberry Pi. Fine. Now, if you want any kind of IoT projects, real-time simulations, real-time image video processing, you can surely do on that. Robotics purpose, avionic purpose, it's a very good board, very good board. If we require a very like strong computation power, you can use it. Now, like also with the availability of that processor thing, we are able to put a OS into it. The normal common OS available for it is the Raspbian OS or Raspberry OS, which we usually call it about. There are multiple other OS available for the Raspberry Pi which we can download, like the Ubuntu OS, RISC OS, Windows 10 IoT Core. You can do with like anything. Like it's available for from various different vendors. But my recommendation will be for this board is the Raspberry OS, the default company one, because like there are many good features available into that folder itself, into that OS itself, and it's much more compatible than any other because it's basically the like the board is designed with that OS only. So that's why it's having the more compatibility with that OS. Next thing, the Raspberry Pi is having the digital like the GPIO pins, the general purpose input output pins, which we have talked about in the Arduino itself, the digital pins, the analog pins. We are also having the digital input output pins in case of the Raspberry Pi as well. Now, one important thing which it requires is the 8 GB of at least minimum 8 GB of SD card to basically store that OS, which will be helping this board to start up. Fine. And with those GPIO pins, you can control almost anything like the LEDs, motors, sensors, camera systems, drones, anything you want to compare, you can control it with. Now, this is a normal speed rate which we are going to see. It's from 700 megahertz to 1.2 gigahertz. This is the amount of uh, speed which we are talking about. Over there, in the case of Arduino, the max to max which we have seen is of 84 megahertz, and it's starting from 700 megahertz. So we can just see towards the availability of that much computation speed which we require for some cases, like in the image processing, in the video processing, we require that speed. In robotic purpose, we require that speed out. Although Arduino is good in many cases to use in the robotics applications, but when we have a very complex system, then we can surely go with the Raspberry Pi. Then, like Raspberry Pi is also having the availability of UARTs, I2C protocols, SPI protocols. These are all for the communication part, like from communication from one sensor to other sensor to one device to another device. These are not directly related to your IoT. It's basically for the communication to how to we can send the data to different devices. These four are basically the normal protocols which are almost available now in almost every device. Fine. Now these are pretty like normal available boards. Now we are also having a new one, the Raspberry Pi 4. This is the first one, the Raspberry Pi A plus. Then we have the B plus, 2B plus, 3B plus, and this is the Raspberry Pi 0W. This is the smallest board, and these are the little big one. The Raspberry Pi 3B Plus is one of the most common and most preferred board ever made in the Raspberry Pi series till 2019. Now we are having a Raspberry Pi Pico as well, which is basically giving a very good competition to the Arduino family. But in case of Raspberry Pi, we also consider like the when we are having a much more complex system, only then we can move towards the Raspberry Pi. Why are that reason is we will be continuing in the lecture itself. So this is basically a overview what we are having with the different Raspberry Pi as well. Just see with the amount of RAM available for this case. Over there it was in KBs. It's in now in MBs. Just see to the speed or the processor which they are using. These there is ARM 11, ARM 12, or ARM Cortex A53 with a speed of 700 megahertz, 900 megahertz, 1.2 gigahertz, 1.4 gigahertz. Now at present with the Raspberry Pi 4, we are having 4 gigahertz of speed. Fine. Also, we are having the ability of like we can have one USB port, 444, and a micro USB port. That depends upon version to version. Now there are some boards like your Raspberry Pi 3B Plus and 3B. These are that's why this is the main reason why this 3B Plus is the most preferred one because it's having almost everything a user a hobbyist wants. If you want an Ethernet connection, it is having an Ethernet connection. If we want like a Wi-Fi system, we are having a Wi-Fi system. If we want a Bluetooth, we are having a Bluetooth connectivity as well. If we want HDMI connection, we are having that as well. And if we want to have a connection to a DAS composite displays, we can also have it. And this micro card, the micro SD card, is a compulsory one for every device because the OS will be installed on that only. Fine. So this is the main thing of the Raspberry Pi, like what we can see in this. Now let's just have a closer look with the Raspberry Pi. This is the four USB ports which we are talking about. This is the Ethernet jack port. This is the audio jack port. These two displays are being used for the camera attachment. This is what we are having HDMI display port. This is the power plug, and these are your 40-pin header for the GPIO purpose. Now, just have a look over this. Micro USB port, power in 2.5 ampere. Over Arduino, what we have seen, I have told you about, like the maximum input current supply should not be crossing a 2 amps rating. This is what the Raspberry Pi lags over. There are many good points with the Raspberry Pi, but there are also very uh, heartbreaking points with the hobbyist for the Raspberry Pi. One is the power requirement. It consumes a lot of power. Like you can just see a 2.5 amps rating. Like we have a common formula for the power, P into I. P is equals to V into I. Like the V is constant for Raspberry Pi as well as for the Arduino. It's 5 volts. But when we consider for I, it's the current amount. For Arduino, it can work from zero point 0.5 amperes to up to 2 amperes. But in case of Raspberry Pi, we require an exact 2.5 volts. Nothing less than that and nothing more than 2.75. Otherwise, it will going to burn out. Nothing less than that, like after 2 amperes, it will not be starting up. From 2 amperes to 2.5, it will be working in a quite a good range. But 2.5 is what is required for a proper functionality or a long go functionality of the Raspberry Pi. So this is the biggest advantage of the Raspberry Pi. Like it's not a power efficient device which we require in case of the IoT devices, because in IoT devices, when we consider in case of the smart devices, which can be a smart car as well, if they are consuming power, they are putting the pressure on your battery systems or your engine systems. If we consider the devices which are available in the wireless sensor network, they don't have that availability to continuously generate power. Either they can have be like battery power, or they can maximum have a solar station, a solar system, solar panel being attached to that. So that also requires much more time to generate power. So this the reason why we consider the power consumption to be the biggest issue with the Raspberry Pi boards. Second biggest issue with the Raspberry Pi boards is we just have the availability of digital pins to be interfaced. We do not have the availability to interface a analog input pin. Like only like in the Arduino, we have the functionality, like we have the 50/50 functionality. We can have the analog input pins. Like we can take the input from the sensors as an analog value, but we are not able to basically generate the analog signal of the sine wave type signals. But that is also being compensated with the PWM functionality. But in case of Raspberry Pi, neither we are able to generate an analog signal, nor we are able to basically take inputs from a analog device. So this is another big disadvantage of Raspberry Pi. So like if we conclude in this case, if we want like Raspberry Pi is a good device, like we are having much more functionality, much more capability in Raspberry Pi, and Arduino is also good device, but they are having some kind of advantages, some disadvantages. What if we just connect both to the devices and we can just overcome with the problems with each other? Like what we used to do is, in case we want some external analog devices which want to take the analog inputs, we just connect an Arduino Uno or a Nano with an analog sensor and send that value to the directly to the Raspberry Pi board, and the rest of thing is done. The problem of analog devices or analog functionality is being removed. This is the way that we take how we can use with the common functionality of a simple devices, and we can club this thing together And this way, we are also able to put that value available in the Arduino to the internet as well, because Raspberry Pi is helping the Arduino to send the data to the internet or to through the internet to any database or to the user. So this is the main point. If there is any doubt till this point, please let me know.
It's fine, sir. So,
Everyone, it is fine, I guess.
Yes, sir. Yes, sir.
Okay, let's move to the next board. The next board is a pretty common one, which you might all have been known about, the Node MCU or the ESP32 boards. They are almost similar, just with the difference the chip, the main control board available in that is different. Like the Wi-Fi main board is different. Like in this case of Node MCU, we have ESP826s. In case of like the ESP32 boards, they have the ESP32 chip as the main Wi-Fi chip. Now, this is basically what brings you out the common like a combination of the good points available in both Arduino as well as in the uh, Raspberry Pi. If we came across to the points, the first point was low power with the Arduino. It's having a low power. It works on 3.3 volts. Second good feature with the Arduino Node MCU is basically is like it can be put into a deep sleep mode to save power. Like suppose there are some devices which requires to send some data on a periodic basis, like after 4 hours, after 2 hours, after 3 hours. So in that case, if we have a clock system around it, then we can just put this node MCU into deep sleep mode and we can save the power. And when we just compare, if we continuously working on that board and then we just put that device into deep sleep mode, if we compare how much power, how much like lifetime we can expect, it's drastically changes. If a single cell battery is providing its power and for a normal day, if it is working 24 by 7, even though over that time it's only sending the values after 6 hours or 5 hours, it will be drained out into 2 to 3 days. Fine. And if we work with that deep sleep functionality, you can work up to 7 days, 8 days, 10 days. It depends upon the availability of your sensors as well. So this is the power of Node MCU. Second more important point, the availability of analog pin. Although it's having only single analog pin for the interfacing, but that too will be giving the advantage like we are able to interface the analog sensors with it. So in case if we require multiple sensors to be interfaced, what we can do is in a common sense where a common part when we use like in we study the digital electronics, from that we get an idea. They're just taking with the normal day study in the colleges, taking an idea of a simple multiplexer. We use the 16 into 4 multiplexer which is available in the market. Use just a 4 pins available onto the digital pins and just use as a select pins for the mux system and just put that into as an input for this. You can interface with 4 pins, 16 different sensors. Just with changing with this time of speed, like the time which we're taking the value from. Like it can be 50 milliseconds delay, it can be 10 milliseconds, it can be after 1 microsecond. So by using this functionality, we can increase that availability of analog pins. So if there is a disadvantage, we have some solutions for that as well. Fine. Now, the next important good thing which is coming from Raspberry Pi, it's having the availability to be directly being attached to the Wi-Fi systems because it's a Wi-Fi device. So we can directly interface some devices with Node MCU, and then we can just send data to the database server or directly to the user. This is what we get with the functionality with Raspberry Node MCU as well. Just with again take into the consideration this is 3.3 volt device. It's not a 5 volt device. Whenever we put a 5 volt device, 5 volt supply to this, it is going to burn out in case you are putting a 5 volt device, 5 volt supply to the 3.3 volts pin. Otherwise, for some node MCU, like whenever you are going to buy this node MCU, there might be chances you will be coming across two different types of NodeMCU only. It's a 12E and a 12, only the 12 version. So the 12E version is basically having the capability, like it will not be damaged if we provide a VIN supply of 5 volts to it. Nothing more than that. Like in case of Arduino, the VIN supply can be taking a max of 9 volts, but NodeMCU might not be working for 9 volts. This is what disadvantage for NodeMCU? Yes, we can consider because we are not having that much flexibility of providing the power to the NodeMCU. Whenever you are going to provide the power supply from the USB, then it's perfectly fine because the USB is going to give 5 volts and that is directly being supplied to your AM 1117 voltage regulator, which will be dropping that voltage to 3.3 volts. So it's perfectly fine. Just make sure whenever we are going to use the VIN pin, nothing more than 5 volts should be supplied to the node MCU. Fine. So this is what is like, this is the three different types of boards which can be easily being used. Now another point which we should be considering for these boards is the cost. This node MCU is one of the cheapest in the series of these three devices. The Raspberry Pi is the most expensive one. To basically start working on a Raspberry Pi, it costs around 3.5 to 3 or 4K rupees. And for the Arduino, you can start with around 300, 400. It's max which we require to have. Fine. So if there is any doubt, please let me know. Before that, to coming to the doubts, uh, in this course, we will be basically focusing on the Arduino as well as Node MCU. Why both the things? Like the reason is if we use the direct Wi-Fi chip, which is available for Arduino as well, this 8 at meg sorry ESP8266, this is a very sensitive chip. Like even a static electricity available into your hand will be going to destroy that chip into a fraction of seconds. So that's why we do not prefer you to basically put your money or waste your money onto that. Next issue with that like your Wi-Fi module is like before using that Wi-Fi module, we need to basically put some 80 commands and we have to configure that board first, which for some boards it works and for some boards it does not. And with this available, like with this problem of this remote connections, we might not be able to resolve that issue as well. So what we prefer is like there is only 100 rupees difference with the node MCU board and the ESP8266 Wi-Fi module. Fine. So we prefer to just whenever we work with the Wi-Fi, whenever we require the Wi-Fi functionality, we prefer to use a Node MCU board. There are many different ways to send data from Arduino to Node MCU, and this is basically more viable because it saves a lot of monetary funds and helping us all of us to be not destroying or wasting money into these stuffs, like just destroying the things out with like even we are taking as much as care we can take. Like in my case itself, I have burned like just because of that static electricity, I have which destroyed around 12 to 16 Wi-Fi shields or this Wi-Fi module itself. So I just forgot that using that thing out and directly shifted towards Node MCU. I just connected an Arduino with the Node MCU and just send the data over it. Or if a project is very complicated, then I use a Raspberry Pi with that. Why I'm also preferring to use an Arduino in this case is there are some sensors which might not be directly being easily being interfaced with your Node MCU board. So if we work with the Arduino Uno or a Nano or a Mega, if we are able to interface that thing with the Arduino, we can directly use that Arduino for interfacing the things. We can send data to the Node MCU and it will be directly be supplying the data to the web server, user apps, or anything which wherever we want. Fine. So this is the main thing. Now, if there is any doubt, you are free. Please free feel to ask. Anyone having any doubt?
No, sir, it's fine.
Okay, so all are good. Like if there is any doubt, you can just please free feel to ask. And the next thing is as well, like if still you are left with doubts, you want like you are not able to convey in the class, you have the group, you can just ping in that as well. Fine. Now like if we are all good with this, we can move with the next lecture. If there is any doubt, you can just ask. Anyone having
Excuse
any
me,
doubt?
sir.
Yes, yes, ma'am. Please go.
Sir, how do you program NodeMCU?
We are going to know like the Arduino IDE will be helping us to program NodeMCU as well. Like that is why we have put it that into a same category, because like the programming thing is almost the same. Just we are going to have 2 to 3 different libraries which will be installed into that. Nothing much different, and that 2 libraries are being a default libraries.
Okay, sir. Thank you, sir.
Anyone else having any doubt? Please let me know. No doubts.
No, sir. No, sir.
So, like the second lecture is very simple. What we are going to do is we are just going to learn how to basically install the Arduino IDE if you are not having that pre-installed into your laptops. So let's just go with this. The interfacing part, the things like how we are going to interface the different things, we will be learning from tomorrow itself. Fine. So for the installation, what we will be requiring to do is we will be going to the Google and then we are going to type for the www.arduino.cc. This is the homepage for that site, and from here we can go to the software section, and from the software section we can just go for the download the slide or download the software itself. Fine. And down next, when you are going to download that software, it will be asking for to agree with the license, and you can just keep on going next. Just make sure, like it's an advice, you want to change, you can do it. If you can put that location for the libraries that drive to be a default one, that will be good. In case like whenever we are going to have some different libraries to be installed into this, we can use that out. Fine. This is a simple like advice or just a suggestion you can use. If you want, like if there is you feel like you want to store that into a different drive, you can surely do that. No issues in that. So this is the basic coding area which we get to the Arduino IDE, and this is some examples. Let me just show you how we get this up. And for the simulation part, like for the hands-on practice, we will be using the Arduino itself in a direct way for some functions, for the some sensors, and for some sensors or the devices, we will be using the ThinkSpeak server, sorry, the Tinkercad for the simulation part. Fine. So as we go for the Arduino.cc, this is the Arduino main site, and in the software section, when we click, this is the option. You can like anything above Windows 7 or newer, you can just download this to your laptop device itself. Fine. Please do not go with this app one. It's basically gives some kind of errors. So I prefer to basically go with this window app functions like the application and install this thing only. Fine. After your installation, you will be having this icon to your desktop. This is your Arduino icon, and let me just open this for a while. It will take 1 to 2 minutes to start, and let me just bring my Arduino as well. Don't worry with this difficult code thing which you are going to look over there. We are going to make these all things very easily. So whenever we just, oh, sorry. Whenever you are going to open with your Arduino for the very first time, if you are like for the very first time it's installed, and if you are going to open with the new file, this is the basic outlook you are going to see for your Arduino IDE. Fine. Now in the Arduino IDE, we basically having two different functionalities, like the two different functions. One is your void setup function, and the second is your void loop function. What is basically your void setup function is like basically is used to uh, set up different things. Like whenever we want to set up the speed at which the Arduino will be talking, whenever we want to set up like some pins, basically like which pin like we have talk about now. Like in the digital pins, we are having pin number 0 to pin number 13 to be as input and output pins. So we have to tell Arduino itself like which pin we are going to use and what is the purpose of that pin, whether it is going to be an input pin or whether it is going to be an output pin. So this is what we are going to consider over this in the void setup section. And if we are including any library, that is also be going to be discussed over here itself. Fine. Now the main thing and the next thing which is coming in this part is your void loop section. In the void loop section, it is the thing which is going to be continuously running for an infinite loop, and your logic will be going to be established over here. Like suppose if we want, like if I pressed a particular button, I want to turn on something. It can be a TV, fridge, or your fan, anything on a light. Then this is the basic logic. That logic will be built over here. Whenever I am going to press that button, it is going to turn on something. This is the logic which we are going to see and which we are going to build over here. Now, as I have said, like whenever you are going to have this installed and you are having an Arduino with you and you want to test it whether it is working perfectly or not. So what we can do is just go to the file section and go to the examples. In examples, we can go with the basic and go to blink. In this blink function, what we are going to do is this is the pre-written code available to basically turn on that built-in LED available in the Arduino, which I have talked about, like which is connected to the pin number 13. Fine. How this function is written, how this like what is this pin mode, what is this output. We'll be working with this tomorrow in the lecture. No worries with that, no hurry in that. So go with the very basics, how we basically upload a code into the Arduino. So this is the code. This is the pre-written code and example code. What we are going to do is we're just going to attach our Arduino board to the device, to the laptop. Then go to the tools, and in the board section, we are going to select the correct board. And in this case, I am using the Arduino Uno. So we can use this Arduino or Genino Uno. This is my board. Then into the port section, this is very important. Into the port section, we are going to check for the perfect port, which is in this case is my Arduino COM port 5. It can be different for any, like for everyone. Like it can be COM port 4, 3, 27, 7, 9, 10. It can be different. Like for my Arduino Uno, it can be 5, it can be 7 sometimes. For my Nano, it is 9. For NodeMCU, it's 7. So this is what I get usually with my board. I'm going to select this thing up. Fine. So we are going to again check for this. The board is Arduino, it is correct. The port is from COM5, it is correct. Then what we can do is we can click on this like tick mark button. This is basically your verifying button to verify or to basically compile that code. Whether we have done any mistake in writing the code, whether this syntax of writing the code is correct or not. Fine. If we just click on this, it will start showing us the compiling the sketch, and this is the progress status over here. So it's done with that, done compiling. And now after done compiling, if our board is connected, what we can do is we can just go with the upload function. So it shows done uploading. Let me just show you that as well. So you can see this is the Arduino board, and we are having a blinking functionality available with the board, which is basically telling that this board is perfectly fine. Now, the next thing which we can use this board to have is we can use this board to print something onto a serial monitor. What is serial monitor? It is basically a device available into a basically a functionality available into our IDE to provide that, like, to basically test for our devices what kind of values we are reading from a sensor, what type of like exact values which is being sent to the board itself, and on the basis of that we can write our logics. Fine. So this is this functionality, like it's basically like we are having a delay of 1 second. For 1 second, it's the LED is on, and for 1 second, the LED is off. So the total time frame or the time period for this pulse is a 2 seconds. So this is what we are having, and then we can have, in case of the functionality, this is the serial monitor which we are having. Whenever we are going to have the serial monitor, we are going to have different functionality, different things which we need to know. For now, let's just see what are those things. So as I have told you, like whenever we require something to be start up, we require that to tell this thing to the Arduino into the void setup section. Don't worry, we are going to have this thing multiple times, so it will be remembered out. So we have the serial dot begin function to basically start our serial monitor. And the serial.begin function is going to basically take an input. That input is basically they take a parameter. That input parameter is basically the baud rate, which is used for sending the packets. That baud rate basically helps or determines at what speed a packet is being, or the packet of data is being transferred. Fine. So there are multiple baud rates available. The default baud rate which we are going to use in many cases, except for the case when we are going to work with the NodeMCU, is your 9600. In case of NodeMCU, a pretty good baud rate which is being used for the NodeMCU is your 115200. Fine. So this is what is your serial monitor, like how we can just see, do this, like to begin this thing up. Another different thing with the void setup section and the void loop section is anything which is written in the void setup will be executed for a single time. In void loop, that will be for infinite time. So if we want to see that different up, let's just have it. Let's just print something to the serial monitor. For that, we require this small commands, serial dot print ln. Like what is this ln is for, basically to write into a next line. So when we are going with the next works, we will be revising these things again. Let's just write, so let's just write hello. And then in the serial, in the void loop section, let's just print serial dot println world. Again, I have written a different code, so need to first compile this code up. For that, like it's not an example code, so we have written this code, so it will be asking to save this first up. Then it will be going for the compilation. It will be checking if we have done any error or not. Fine. So if we have done and not, we haven't done any error in this writing. And then what we're going to check it for is the Arduino board and the COM port. If these are correct, then just click on the upload button. So it's being uploaded now. Now, when we click to a serial monitor, we can see like need to first go to this baud rate selection, and you can see it's 115200, but we have used the 9600. Again, you can see like from 300 it started, and you can use any baud rate you want to use. The max for the Arduino where it can go is up to 115200. Fine. So the pretty good one is your 9600. It is not going to basically. So this is what happens when we just write. You can see we are having. Let me just have a auto scroll connect. Okay. What I require is to put a delay as well. Otherwise, we are not able to see anything out. Basically, a delay function which we can use. We will be using this very often in most of the programs. So what this delay function helps us to basically this delay functions takes an input parameter. This input parameter is basically the for the amount we can be used for like the amount of delay we want to have from being executed for the next command. Before executing next command, for this for much of time, the delay is there. Now this delay value is in milliseconds. So in order to put a value of 1 second for a delay of 1 second, we will be requiring to put a value of 1000 in that. Fine. Let's just upload this thing again. Now you can see we have a hello, this which is written for a single time because that was in the setup section. Next, we are having the word into the loop section, and since it is in the loop section, it is being print for infinite number of times, and it is being updated after every 1 second. So this is how we can just check whether our board is working perfectly or not. Fine, everyone. So till this point, if there is any doubt, please let me know. And the rest class we will start with tomorrow.